Hello guys, hello everybody. I'm back for the part two of this balanced chemical reactions refresh. Actually, we have 15 numbers here and all are completely balanced except for number. The chemistry teacher of the particular student, okay, gave this example, ferrous chloride, chloride, or chlorine gas. Or gas, if we have Cl2 subscript, that is the atomic molecule, okay, the atomic atom, something like that. Two means die, right? Okay, so let me explain for a while, okay, why it is not possible to do that. Okay, okay. In the first place, okay, ferrous chloride plus chlorine gas. In the first place, there is already chlorine in the ferrous chloride. And then why you need to add chlorine gas out of it? Okay, so the more it will become, and then why you need to add chlorine gas out of it? Okay, so the more it will become over with chlorine atom. So that's the first ideology or the first, shall we say, philosophy. Okay, that could I say that will never hold through. Okay, let's have the balancing now. Okay, just to prove have the balancing now. Okay, just to prove this reaction to be correct, existent or not existent, something like that. Then if that is not really existent through your proven analysis or through your breakdown of your balancing equation, so meaning to say that is not really existent and that is hypothetical only. It's just a reference to a student how to balance, but it doesn't exist in reality, something like that. Okay, because just to measure the learning of the students, how they apply the rules, okay, for that particular type of chemical reaction. Okay, so sometimes like that also. Okay, so this is number 10. Oh my gosh, ferrous chloride. Oh, I have to get this pen, right, to make it visible enough. Wow. Oh my gosh! Number 10, no? Question number 10. Ferrous chloride, gosh, plus chlorine gas. Okay. So, ganon. The product is ferric chloride. Okay. If you try to balance this immediately, you can see that the iron, Fe is iron. Okay, iron involves in the process of corrosion. Okay, if you see pipes are corroding, moisture or acid rain, okay, iron is responsible for that in conjunction with the reaction of water. Water could either be a rain, okay, a normal rain or an acid rain, okay, or it could be a moisture only or a steam. STEAM is also a water in a vapor state. Okay, so it will be enough to produce the corrosion process. Okay, so actually this is iron chloride for corrosion process if we have iron in the reaction, something like that. Okay, but this one, see, your product is ferric chloride. If you try to balance the iron, is not an issue. But if you try to balance the chlorine, there are 4 atoms of chlorine in the reactant, and there are only 3 here. Then let's balance this. Let's try again to use the algebra. Okay, algebra, linear equation. Okay, like that. Okay, so Fe1, like this. Okay,
And let's adapt the concept again of law of conservation of matter, or law of conservation of energy, or the law of conservation of mass. Okay, like that. So the number of atoms in the reactant should always be equal to the number of atoms in the product. So we mean that is the total number of atoms. Okay, like that. Or the total amounts generally of the reactants equal to the total amounts of the product, something like that. Okay. So chlorine here is 4. There's imbalance, right? See, imbalance. So the rule of balancing equation, you need to go in the side where it is an deficient number atom. Of course, you have to add there because that is deficient, or else you will defeat your purpose. Okay, so you will be going there. So it's in the right side that you need to let X as the number of atoms added to 3 so that it would be equal to the number of atoms here in the reactant, right? So it could now be like this. X. X is the number of atoms that we need to find out to equalize or to in equilibrium with this in the reactant. Okay, so applying algebra, linear equation only, shape solve equation. Okay, 4 is equals to 3x, or x times 3. This one, x times the subscript. Okay, that's the total number of atoms. You have to multiply the subscript always. Okay, subscript, so that is the number of atoms. Okay, and on the side is only the number of moles. Sorry, the number of moles will not carry the subscript, but the number of atoms will carry the subscript. That's the only difference. That's why in the law of conservation of energy and law of conservation of mass, it's not the total number of moles are balanced between the reactant and the product. It's always the atoms. Okay, if you try to find out that, because that is not the theory and principle behind. It is always the number of atoms. Okay, but if you try to consider the number of atoms, it always be take note the subscript. This one, the numbers in the town level, something like that. So this is 3. So 3 times x, something like that. So solve x. Improper fraction in algebra. Improper meaning the number in the numerator is higher than the number of the denominator. Something like that. So it's improper. Okay. So like this. So we need to avoid whether it's a proper fraction or improper fraction in our chemical reactions, because it doesn't exist in a natural process in a chemical reaction to have that fractional number of atoms. Okay, we need to apply again algebra. Okay, we need to put now the x 4/3 besides the ion here, right? Okay, FeCl2 plus chlorine gas is equals to 4/3, like this. See? Okay. Now, try to balance. Iron, it's not balanced after obtaining that 4/3. Okay, but your chlorine is balanced. Okay. Understand? Is balanced. Chlorine 4 and chlorine 4. No, we need to multiply both sides by the denominator of this fraction, by 3. Okay? No question, huh? That's already the rule in algebra. Okay? So 3 moles of FeCO2 CO2 plus 3 chlorine gas is equals to 4 Fe charot ay plus 4 4 iron chloride. This is gonna be like this. So 3 ferrous chloride plus 3 chlorine gas plus 4 moles of ferric chloride. And then if you balance the first ion, it will never be 12. And the chlorine is balanced already 12. The problem will always be the iron. Okay, like this. Now, if you balance again and again and again and again, okay, if you balance again, let's say iron. So 3 iron here and 4 iron here. So we let X beside this iron here, right? Because this is deficient equals 3X. Okay. Solve the value of X is equals to 4 over 3 again. Like this. So like this. Okay. We balance the equation again. So we start with iron. Since iron 3 is iron 4 here, not balanced. So we need to let X for iron in the ferrous chloride. So this will become 3X. 3 times X. So 3X is equal to the 4 here. So X equals to 4 over 3. And the 4 over 3 will be replaced here. So 4 over 3 times 3. 4 over 3 times 3 is equals to 4. So 4Fe. Okay. 4 ferrous chloride plus 3 chloride gas is equals to, okay, 4Fe. Clear. So 4, okay. The iron are already balanced, 4Fe and 4Fe. So our problem is chlorine. So chlorine here is 3 times 4, 12. Here, 6 plus 8. 14. So the chlorine also will never balance again. So in this case, if you try to keep on repeating and you obtain a fractional form, then you can sense already there's something wrong with your reactant because you keep on repeating like this, and you'll never obtain the correct balanced chemical reaction. So in your reaction, this chlorine gas, it could have been chlorine solid will react to FeCl2, not the gas. Why? Because it produces iron chloride. Okay. Don't you think if you add chlorine gas will produce a solid, one solid? Just common sense. If you add a gas and a solid and your product is a solid, by common sense, you will get a solid product? Answer me yes or no. If your reactant is solid and a gas, and your product is a solid, where is the gas now? It lost. That's only a simple common sense. So their teacher gave the wrong example. There will be no ferrous chloride plus chlorine gas existing naturally. Okay. This is the point. It could be chlorine solid because your product is entirely a chloride is a solid. Okay, and you add solid to solid, normally your product will be solid. Okay, that will be pen or ball pen. It's not pentel pen because you added only the pen. This one. Okay, ball pen plus ball pen is equals to ball pen. Okay, 1 ball pen plus 1 ball pen is equals to 2 ball pens. It's impossible you will produce a pentel pen. Okay, because pentel pen is not added in the initial stage. It's just like this. Okay, ferrous chloride is a solid plus chlorine solid, it equals to iron chloride, not chlorine gas. So technically, example given by the teacher is wrong, teacher. Okay, so this is definitely wrong. It could be ferrous chloride plus chlorine gas. Now, let's show you the correct reaction, okay? Ferrous chloride plus chlorine as a solid substance, okay? Because chlorine, if it exists as a chloride, it is a salt. If it exists as a chlorine, solid. If it exists as a gas, it is Cl2. Okay, there's a difference. Okay, chlorine alone, solo, meaning free atom without any charges, without any subscript, is simply chlorine solid. But if you put subscript 2, that is diatomic gas already. Okay, but if you put negative in the charge, that is chloride, that will become a salt. Okay, so this chlorine thing will exist in three behaviors. Okay, three behavior will act as a halide. Okay, first we act as a gas, the atomic gas, and act as a solid, as a free atom. Okay. I hope that the teacher will express and explain like this to the students. Chlorine will exist in three behaviors, something like that. Chlorine as a chloride, as an example of a halide. Chlorine gas with a subscript 2 as a diatomic gas, and chlorine as a solid without any charge and subscript, but a free or solo atom as chlorine, so that the students can really understand the behavior of chlorine. Okay, like that. Okay, so this is iron chloride, FeCl3. Now take a look. If you change the chlorine gas with chlorine solid, or an element solid, not a gas, then automatically it will be balanced. Take note, iron 1, chlorine is 3, and chlorine is 3, right? Perfect. Okay, the atoms of chlorine in both sides are already balanced visually and ideally. Meaning perfect without doing anything. Okay, we did not balance it, we're just looking, but after looking, we automatically have the perfect balanced chemical equation. So that is ideal behavior. Okay, natural, without any adjustment of the number of atoms or anything during the chemical reaction. Okay, so this is the correct. Okay, this is the correct chemical reaction number 10 out of this 15 examples given by the chemistry teacher. Okay, and now I will discuss also number 14. Okay, the chemistry teacher give methane plus oxygen gas, this one is equals to chlorine gas plus water. Meaning only, I think, only clerical error. There's a lot of factors also, not really that sure, right? Okay, clerical error, only overlook, something like that. Okay, I'm just explaining that it's wrong technically, okay? Because sometimes you commit errors, right? Only methane plus oxygen gas, and then why your product have chlorine gas? Where is chlorine gas coming from? Your reactant has no chlorine at all. So this is impossible. What comes in comes out. If it comes out, at least there is a behavior to be same as with what comes in. Very difficult, right? Input is equals to output. And it is expected that your input will be equal to your output. And if that is not found in the input, it looks like impossible, okay? Or non-existent, okay? There's no chlorine in the reactant, then why the products have chlorine? So definitely technically wrong, okay? So water is correct because water is the product of combustion. Okay, every combustion process, it will yield to water and carbon dioxide. So supposedly this is carbon dioxide instead of chlorine or chlorine gas. Okay, CO2. Naturally, underground, something like that, without any chemical reactions involved, something like that, without any adding catalysts, whatever. So methane gas, or CH4, is the simplest hydrocarbon family and the simplest alkyl group. Okay, this is methane gas, natural. Okay, meaning to say, if you're producing methane gas, so that company is not really that buying so much technology, that much compared to obtaining propane, butane, propane, because there's a lot of process for that. Okay, because this is naturally occurring element, compound, sorry, naturally occurring compound, okay, because this is carbon and hydrogen, that's compound, okay, like this. So CH4 plus O2 is equal to carbon dioxide plus water, and let's balance the chemical reaction. Okay, number 14, no? Okay, CH4 methane plus oxygen gas If we mean oxygen gas added in a reactant, that is automatically rapid oxidation, huh? Undergoing the process of oxidation. Okay? So meaning to say, there's a loss of electrons. Okay? Okay? If it is an oxidation process, there's a loss of oxidation, something like that. Loss of electrons. Okay? Oxidation reduction refers to electrons, huh? Not protons. Always electrons. Electrons lost, electrons added, electrons gained, something like that. Okay? Remember that. Always electrons, not the proton. Okay? Something like that. Something will also confuse in the examination. How many electrons will be shifted or shared? But that is not proton, that's electron. Sometimes always like that also. Okay? They try to trick you out and because like this, the charge are passive, something like that, because the charge of a hydrocarbon are positive, right? So the students will normally think proton, right? And the charge of oxygen is negative. So what we are referring here is the negative charge. It's not the positive. When we do the rapid oxidation or the oxidation reduction, something like this. Okay? So this is CO2 plus H2O. Okay? Balance the chemical reaction, ganan. Okay. Carbon 1, carbon 1, hydrogen 4, and hydrogen on the other side is only 2. So let X the number of atoms added to H2 so that it will be equal to the hydrogen atoms of methane. So 4 is equals to 2x. Solve the value of x is equals to 2. Okay, that's why most of the students will be confused because the teacher also uses trial and error method. You know, trial and error method, they keep on assuming any numbers on the right, on the left, so that it will be equal. But the correct solution for it, it's not like that. Okay, you need to follow the law of conservation of matter or law of conservation of energy. So if you equal the reactant and product, equal means equals in mathematics. Okay, equals. So you can really convert that into numerical and variables, and you can really solve the value of the variable. Okay, like that. It's not really that trial and error, because trial and error sometimes very long will be detected the correct one, and then it will take time also to balance completely. And this is really theoretically balanced through the linear equation. Okay, algebra. Okay, because before when I was in college also, I confused. What's really the technique for this? Okay, through constant exploration, I'm already a registered chemical engineer. Just now I found that it's gonna be like that. Imagine how many years that I already found. It's very late, right? It's not in my college years that I discovered this. Okay, when I am already working in Saudi Arabia, UAE, Taiwan. Imagine I took my chemistry subjects that was 20 plus years ago, and then just now I learned the basic concept that it's gonna be like that. Okay, because teachers are explaining that a trial and error method, keep on changing. Carbon, one on the left, carbon on the right, and there's a possibility we will be wrong because you can assume any number so that it can be equalized. Actually, there's a basis for that. We will use the algebra really. Okay, let the value of x as a number of atoms, put that in the deficient number of atoms and solve the value of x. Something, and that is your number of atoms. And perfect. You will be perfect in all balanced chemical reactions. I wish I got this when I was in my high school in college. Okay. It's too late, but never mind. I can share this information to any students, chemistry students. Okay. So X is supposed to put that 2 in the reaction. So CH4. Okay. I'm not teaching you the trial and error. Huh? I'm teaching you the algebra really. Okay. It's equals to CO2 plus 2 moles of water. Okay. Because I will tell you. Okay. Okay, this is for hydrogen. Okay. and this is hydrogen gas. So most teachers in high school or even in college, because this is 4 and this is 2, they will automatically times this 2 in order to be equal. That's wrong. That is not basing that with the theory. The theory in chemistry, okay, the total number of atoms in reactant should always total to the number of atoms in the product. Okay? Now, 4 equal, because that is equals, equals 2x, because you let the number of x, the number of atoms of hydrogen is deficient. Solve the value of x equals 2. That's gonna be like that in teaching, not the trial and error. There's a lot of numbers from 1 to 10. If you assume it to balance that with the right, so there's a possibility the students will become wrong. Okay? So that's the technique. Use linear algebra to balance the chemical equation. Okay? Like this. Okay? Though this is very easy in a trial and error method, but what if you will go to the higher chemical reactions? For example, you are taking BS chemistry, BS chem, BS pharmacy, medical technology, BS biology, or medical doctors, what else? Forensic science, biotechnology, biochemistry. Right? Then if you start the thing you cannot understand well, then how much more complicated chemical reaction already that involves a lot of fractions like this, blah, blah, blah. So you will never understand, right? So it will start with the basic so that you can understand the complicated one. Okay, like this. Put 2 here because this is the X of water. Okay, like this. And balance. Okay, carbon 1, ganon. Carbon 1. Hydrogen 4. So like this. See? Hydrogen 4. Okay. Okay. Oxygen 2. Oxygen 2. See, investigate balance automatically. Perfect. Okay. So methane gas plus oxygen gas is equals to carbon dioxide plus water. Okay. Okay. Water can exist in 3 phases of matter. It could be a steam that will vaporize. Okay, like that. That will be undergoing the heat of vaporization or the evaporative cooling, right? Right, remember that one? The quantity of heat of 1 gram of water to change into vapor, right? Like that. And then it could also act as a solid when it will become freeze at 0 degrees Celsius, the ice, okay? And an ordinary liquid that we drink every day. So 3 phases, 3 states of matter, okay? Like that. So that's why it's okay. Maybe you will see also, so Sotero, you add all gases here, the oxygen gas and the methane gas, and why there's a liquid? Because liquid to the atmosphere, something, or evaporate, the molecules will evaporate to the atmosphere, okay? So no problem for that, okay? The only problem if our product here have solid, okay? Because your reactants are all gases, and why there are solid products. So by common sense, it will never hold through. Okay, something like that. Okay, so this is a perfect balanced chemical equation. Methane gas plus oxygen gas is equals to carbon dioxide plus water. So this is undergoing the rapid oxidation or the oxidation process, the loss of electrons. Okay, something like that. Oh my God. So that is number 10 and number 14 is wrong. Okay, and the rest will be correct. This one. Okay. I love really teaching, right? It's very enjoyable, okay? Like this. Actually, I planned to become a teacher a long time ago already, like this, but I never continued that, okay? I already submitted the application, something that never pushed through because of some, like this. Okay, now let's go to the, handshake brought to you by Powdered Alaska. 96.3, totally rock. Okay, let's go now to acetic acid, propionic acid, and butyric acid. Oh my gosh, butyric acid, Sotero, wow. So butyric acid, oh my gosh. So butyric acid is a short chain fatty acid. So we need to classify the fatty acids into two types, the short chain fatty acid and the long chain fatty acid. So butyric acid is an example of a short chain fatty acid, just like a malic acid. Okay. And then the long chain fatty acids examples for that are stearic acid, oleic acid, linoleic acid, palmitic acid, and the rest of the carboxylic acids. That has a long chain, carbon and hydrogen chain, something like that. Okay, so these fatty acids are the main source of body fats in our evidence that the fats are not digested completely. Okay, it could either be you have a poor metabolism, weak metabolism, or it could either be your digestive hydrochloric acid or the digestive acid is less, that it's not enough to digest those fatty acids or saturated fats inside your digestive system, or released in the liver, something like that. Okay, because the liver will release the fatty acids, right? Okay, so that's the main reason behind. Okay, another technique to solve that issue is to read the nutritional facts in the packaged foods. If there is a lot of trans fats, saturated fats, then that's not good for the health. Okay, but if there is a level of unsaturated fats, that would be okay, because unsaturated fats are good to the health. Okay, just like eating cashew, peanuts, okay, green peas, something like that. Okay, using olive oil, canola oil, sunflower oil, the beans, beans, okay, and the high fiber quality wet bread, the oats, oats, okay, like that, and some citrus fruits, okay, that have also good unsaturated fatty acids, something like that. Okay, that's also a fat, but it could be easily digested. Okay, because what contributes the bile fats in your waistline are the saturated fatty acids. So junk foods, okay, burger, rice, okay, meat, jelly ala tool, okay, if you eat everyday meat, okay, something like that. And then that's why you need to balance also if you eat meat, something like that, okay. It depends on your, it depends on your cycle of your body's metabolism actually, okay, like that, something like that. So butyric acid again, okay, my gosh. So class, butyric acid found mainly in butter, 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 and in the ghee, Ghee. Okay, it's like a formulated batter, you know. So butyric. Just remember the word B. Okay, butyric, so batters. That is your identification, right? Okay, butyric acid. Oh my gosh, the formula will be CHO, like this, huh? C4HO, H8O2. For just like me before, I memorized. Okay, because if you memorize, then there's a possibility it will retain to your brain, right? Especially you are young, then your memory retention is very high, right? Then as you grow older, because there is a drop of the collagen protein, then your memory will be also declining, right? So you need to have technique really, okay, aside from memorization. Okay, memorizing is good, but you have to understand and analyze what you are memorizing. Okay, because it really helps to memorize also. But you need to, comprehend well what are the technique after memorization. Okay, because every students will memorize. Nobody will memorize. Okay, all students will memorize. Okay, I'll tell you frankly. Okay, like that. So butyric acid. So C4H8O2. So our identification here is the four atoms of carbon. Okay, because this is carboxylic acid group. Okay, andyan na naman tayo. So carboxylic RCOOH. Oh my gosh, like this. Okay, functional group, right? Organic functional group. The R will be your alkyl group. Okay, now, so since four atoms of carbon, if you remember the theory of hydrocarbon, four means the butane, right? Four. So we start with two ethane, three propane, four butane, five pentane, six hexane, seven heptane, eight octane, nine nonane, 10 decane. Okay, memorize that from starting from ethane. There's no one, because the one is simply methane. Okay, methane, meaning one carbon atom only. Okay, methane, ethane, okay, propane, butane, pentane, hexane, heptane, nonane, decane. This decane is not used all the time, but this will be used in saturated fatty acids because the carbon of atoms there are more than 18, or more than 16, or more than, a long chain of carbon atoms. That's why you need to memorize this because you need to use that in naming the fatty acids. For example, 1,3-decanoic, ganon. 1,4-decanoic acid, ganon. So meaning 10, and then the double bond will be on the numbering, something like this. Since 10 will be the basis because the basis is up to 10 only. That's why it became. So it will become acid, so that is decanoic. Okay, because IC will be added. The rule. Okay, just like hydrochloric acid, like that. Okay, remember phosphoric acid, sulfuric acid. We will add always IC. Why IC? Not decanose. Okay, because that is already too high. We base on the maximum level. There's no decanose acid. It's always decanoic. Okay, like this. Okay, in organic chemistry. Okay, that is 10 or more than carbon. Is 4 atoms of carbon. So this is under butane. Okay, butane. Ako makalimot ka, kuno na alam jud mo, charot. Okay. Butane. I don't speak in Bisaya because I found it, awkward. Okay. So, butane. C4H8. Okay. Then there are times that you can remember only the number atoms of carbon, but you forgot the number of atoms of hydrogen. The technique is you remember the 3 formulas. CnH2n is for the alkane, like this, ganon. Okay. CnH2n minus 2 is the alkene, double bond, ganon. Okay. CnH2n is the alkyne, triple bond. But never mind with the double bond and the triple bond. It's not always used all the time. Okay. But the alkane is usually used all the time, the CnH2n. The number N meaning the number of carbon atoms. Okay. N is the number of atoms. So in here, so CnH2n, so N is 4, 2N, so tau times 4 is equals to 8, that was C4H8. Now we will apply that here to the carboxylic acid so that it will become a butyric acid. Okay. Like that. Your clue also is the first letter. Okay, if it is butyric, so in that alkane family and in that hydrocarbon family, so there's only started with B, so butane, like that. If it is propanic, so there's only propane there. Okay, so use propane like that as a clue, the first letter. Clue already. Okay, acylic acid, something like the example only. So that means use the ethane as your basis, something like that, so that you can easily detect. Okay, here butyric, so there's only butane there. First letter is the same, so use the butane. Okay, aside from the number of atoms for butane, so that you have additional identification also. Okay, like that. So you will now try to substitute, right? Okay. So actually, this is our alkyl automatically. C4H8. This is alkyl already. Actually, we need to substitute that in the R, right? So C4H8, C, oxidate H. Okay. This butane is an alkyl, capital R. We need to substitute in the carboxylic acid functional group. It will become like this, C4H8, C, double bond oxygen equals OH. Now, if we will try to put this immediately in the R, it will deviate the formula of carboxylic acid. So, because it's too much, we will need to adjust the hydrogen. Okay? So, since we have 4 carbon atoms, so this carbon here, the functional group, is always included also in the carbon 1, carbon 2, carbon 3, carbon 4. So there are 4 carbons. Include this in counting so that we have the carbon 4 atoms here will be equal. So let's draw. Okay, so draw first the carboxylic to make it sure. Okay, carbon, double bond oxygen, single bond hydroxyl, something like that. And then 4 carbons. So 1, charot, 2, 3, 4, right? There are 4 carbon atoms here. So 1, 2, 3, 4. The 1 represents the carbon of the carboxylic functional group. Do not touch that 1. And then, in that case, there are carbon 4 already. 1, 2, 3, 4. And hydrogen will adjust after establishing the total number of carbon atoms. That's the technique. Do not focus on the hydrogen atoms because it will just adjust after substituting in the carboxylic functional group. Okay, since we know that this is only an alkane, single bond, and there is a covalent bond, okay, the sharing of electrons. So it will be distributed evenly because this is butane. This is not a double bond. So it will be distributed properly. So there's an equal sharing of electrons with the hydrogen to carbon. So since there are 4 electrons in the outermost shell of the carbon, then put hydrogen each, okay? Like this. H, 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 H. Ganun. So, okay? Ganun na siya. Okay, now count the hydrogen. How many, including the OH? 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like that. So the 8, right? So 8 all. So to be okay, right? Because this is an 8 here. Okay. Because if you try to substitute directly the CH4H8 in the R immediately, 8 hydrogen plus 1 will become 9. Okay, so that's why we need to break down that 1 here in the carboxylic function group so that we can adjust the number of atoms of hydrogen. Okay, the first thing is carbon atoms first. Okay, like that. Okay, any questions so far? Okay, so now we can simplify this one as CH3, 1, 2, 3. CH3, right? 1, 2, CH2. 1, 2, CH2. And here, COOH. If we try to put the general formula for this, okay, and simplified formula we mean, we don't put the double bond already. Okay, the double bond, the triple bond are negligible in putting that in a general formula. So this will be like this. CH3, CH2, CH2, COOH. Oh my gosh. This is now the butyric acid. This is the acid found in yogurt. Okay, that responsible of producing butyrate in order for our digestive health to be functioning good so that we have a good bacteria to fight the viruses and the bad bacteria in our body. Okay? So without this, so the bacteria and the virus will never die. Okay? So we should have this, okay, butyric acid, because butyric acid, this will convert to dietary fiber that is very essential to provide 70% of energy to our colon cells in our digestive system, which are the large intestine and the small intestine. Okay, di ba? Ang saya-saya if you really understand the chemical reaction, okay, we can really understand why, something like that. Okay, so without this, so we will die because our digestive health is not normally functioning healthy, right? So that's why we need probiotics food. Okay, probiotics food. Okay, actually, through my research, it really made me survive, and it's really a good weight loss program. Okay, because at night I will never eat rice. Okay, I will never eat, white bread. I will never eat kabosh this time. I will only eat yogurt. Okay, and then I survived. Imagine only one yogurt full fat. I survived. That's only my dinner, plus the grapes, oranges, banana, apple. But if you do your weight loss program, it's also a sacrifice financially because it's very costly to do the ketogenic diets, and you have a weight loss program, a better selection of a healthy food and drinks. It's really costly. That's why I tell you also. Okay, so you have to gamble in terms of expenses in a month. Okay, just to continue your healthy lifestyle, something like that. Okay, but only one time in a day I will eat yogurt, not breakfast, lunch. Like if it is the case, maybe I don't know also what's happening to me. Okay, only one time only. Okay, dinner. I choose dinner because at night we don't do too much activities at night, right? We are just sitting, watching videos, and it will never burn. Okay, if you eat too much rice, then you are only sitting, then it will accumulate in your stomach. Common sense. How can it be burned? Okay, if you are just sitting only and watching videos, it will never burn. So the possibility is it will exist as a bile fat in your stomach. That's why your stomach will become big. Okay, that's why it's best to do the less carbo intake at night. And the breakfast will be your heavy food. Okay, the breakfast, or it could be the lunch, because in that time you are really doing the physical activities, sweating in your work, something like if your work requires you too much energy. Normally you will eat that much also, heavy meals, of course. Okay, that's common sense, right? Okay, but at night, no need to do that because you don't have physical activities at night, right? Only sleeping, only watching like that, okay? But if you love to eat, okay, that's your choice, okay? Because that's your behavior and personality. We cannot do about that anymore, okay? That's your right, being an individual. I'm just only saying the right way, okay? Something like that. So this is the butyric acid, okay? So our intestines needs dietary fiber, to give energy so that it will not break and cut easily. Okay, during we eat foods that are solids and try to penetrate on the outer layer of our digestive tract or lining, something like that. Okay, imagine the formula. But if you can still simplify this one, it could be like this. Check. It could be C4H82. Count. Carbon. 1, 2, 3, 4. 4 atoms of carbon. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms of hydrogen. Oxygen, 1, 2, oxygen, 2. So it's the same as C4H8O2, in which you memorized previously. Okay, so if you forgot, just try to have this theory, and then you can formulate the formula perfectly. Something like that, okay? Not only just memorizing, okay? Though it's very essential, but you have to prove, okay? Like this. Okay, so that's very important for our digestive health. Okay, and this is also the reason why to prevent a leaky gut. Leaky gut meaning there's a leak in your gut, just like a pipeline. Okay, there's a leak of water in the outer layer of the pipe. It's just like the principle behind also in our digestive system. Okay, the probiotics in the pipeline could only be a catalyst that will be applied to the water so that it will, it will never react to the outer layer of the material's construction and promotes rusting, especially water. I'm referring only for water as our medium, medium, meaning it will go inside the pipeline. So water usually causes corrosion. Okay, that's the the practical approach to discover always because that's water, and then it will react to iron, and then ferric chloride, something like that. Okay, if there's no water, there's no rusting. Okay, rust, R-U-S-T, yellowish solid substance. Okay, that's rust or iron chloride. It will never develop without water, Okay, so just like that in our digestive system also. Okay, so if we don't have these probiotics, so though it is not rusting inside the digestive system, then it will be leaking. That's why it's called leaky gut. Leaky gut is one of the causes to develop a colon cancer. You know colon cancer? It's in the intestines. If you keep on eating solid substances, solid food, just like shrimp, okay, crab, like that, or any fruit that have a very thick skin, like apple, okay, tomato, you will never, digest it very well in your, mouth or in your teeth, something like that. Chew it properly before, swallowing, because it will really, penetrate to your colon membrane or the cell membrane of your digestive tract. Okay, so it will cause cancer. Okay, something like that. That's why colon cancer is an expensive disease. Okay, because it only be happening to the most of the times to rich people, because rich people loves to eat like those kind of foods, right? Shrimp, like that. So crab, lobster. So those have a higher, higher skin, hard skin, not higher, hard skin, something like that. Okay, so sometimes it will not be when you remove the skin, and then it will not digest it properly. So that's the main cause of the colon cancer. Okay, like that. So if we eat too much probiotics, that would help also. Okay, like that, to increase the level of our good bacteria in our microbiome family. Wow, perfect. Microbiome talaga. So it's very good, right? You have to combine the biology, the chemistry, the physiology, and the anatomy also, right? The functions of each organ in combination with the epidemiology, the study of the disease and the controls, right, of the diseases and the prevention. And you combine also that with physiology, the behavior, okay, of certain substances that will try to react in the particular organs, and then the chemistry involved also there in the chemical reactions in the protein, water, fats, steroid hormones, DNA. Bingo, you can really understand. And then we can prevent any diseases to occur, and then we can save money also in the future because we are extra careful to our health. Okay, because the doctor will never tell that. Okay, because if all doctors will tell that to us, then there will be no patients anymore. Okay, you get the point. If the doctors will tell you everything, how to prevent, what to prevent, then all are healthy, unless they are really very cruel and very hard-headed to not to follow the doctors. So most of the times people are following the instructions or the prescriptions of the doctors normally, right? Because we pay money for them, right? Normally. So some doctors are not really revealing all. Okay, it depends. If the patients will ask that much, they will also answer. They will never voluntarily say this like this. Okay, because if they say that one, then the patient or the people will prevent already, and then how can they gain money? There will be no patients anymore in the hospitals like this. There will be no more medicines prescriptions by then. Okay, because all the individuals all over the world are very aware now. What are the food to eat? What are the drinks to intake? And they're very conscious now. What are the diseases will come in, right? So that's gonna be the process. That's why you'll never tell everything also. Okay. So that's the first thing to do is to research for yourself, explore for yourself, unless your course in college having medical subjects. You can really understand also some of the basic part about epidemiology, okay, physiology, anatomy, and the chemical reactions inside your body. Okay, but most people are understanding this are those medical professionals. Some also are sciences courses like us, okay, biology, okay, chemistry, chemical engineering, biochemical engineering. We have solid sciences subjects in our accountancy, taking mathematics. Okay, they don't have also very rigid sciences. What will happen to them? Okay, those people will try to research by themselves. Okay, because it's not being taught in their subjects when they're in college. Okay, self-effort or try to have their own initiative about healthy lifestyles, right? Because it doesn't taught in their college. Good for medical professionals in their college, they're teaching that to their students. Okay, the doctors, the nurses, like this, the medical technologists, the pharmacists, the nurse, they are teaching that every in their subjects. But what if the other courses, that's some mathematics courses, courses that involves money or finances or accountancy, business and finance, administration. Okay, how about those people? Okay, so for me, really, the best program for that is our, politicians or our senators would always include medical subjects in all college students, not only for the medical students. That's the best thing. But the problem is, again, the medical professionals will complain because they cannot obtain money anymore after their graduation because the other courses already having the knowledge what to prevent diseases, what to eat. Okay, I think it's also a business, right? Okay, a conspiracy, by the way, conspiracy, meaning an internal arrangement because if they do this, they will never gain money like that, blah blah blah, so and so. Okay, it's a sort of business, right? Okay, just like in the Philippines, right? So in the Philippines, we don't have Bachelor of Science in Occupational Health and Safety. Okay, we don't have that as a course. But in the UK, United Kingdom, United States of America, and some parts of the world have Bachelor of. So why that course is not being implemented in the Philippines? Okay, because it was politicized. Because if there's a subject or a course like that in the Philippines, okay, no more training centers, okay, because it's in their subjects and there's a course for that. So those people are closing their business regarding health and safety and science training centers. Okay, they will really choose that as a course, okay, rather than training only. The training only is 1 month, 2 months. It's short time compared to studying that in how many years. Okay, as a course, Bachelor of Science of Occupational Health and Safety. We don't have that curriculum in the Philippines. Okay, I think India have that. I think so. Not really sure. Okay, because if you try to put that in our country of origin, so a lot of safety training centers will be closing down. Okay, of course, we will prefer to study rather than training only. Okay, like that. It's just like that also with the medical courses. They don't put medical subjects in engineering courses, in the administration, in the bank and finance courses, psychology courses, in the education courses. There's no medical subjects because if you try to input that there in their subjects, they were very knowledgeable enough after the graduation, and then only few will get this sick. Only few will have diseases, and hospitals will only treat and cure few, right? Then their salary is very low. Of course, the law of supply and demand. Okay, there will be an effect for that situation. Okay, Because for me, we need really medical subjects so that we can understand. Because our purpose here on earth is to live, okay? We are here to live on earth. Nobody wants to die immediately. Nobody wants to die early, right? We want to live to the fullest so that we can reach an age of 60 plus. Then if we don't know really what are those diseases, what to prevent foods to eat like this, healthy lifestyle, and then we will die immediately or we will die very early, right? That's why so many people suffering obesity, overweight, type 2 diabetes, stroke, heart attack, okay, like this. Heart attack is myocardial infarction and stroke is cerebral infarction. Okay, that's medical terms for that, okay? Again, stroke is cerebral infarction, okay, and then heart attack is myocardial infarction. Myo meaning the heart, M-Y-O, and the cardial through cardiovascular, something like that, okay? So that's the medical terms, okay? So usually people die in a stroke, okay, because there's a poor circulation of the blood going to the blood vessels, okay, something like that. It's being clogged because of the cholesterol deposits, too much sugar, something. So really, but if those guys knows at their young early age, then there will be no problem, right? At their 20s, at their teenagers age, they know that already that concept behind epidemiology, meaning the study of disease prevention and control. So there's no problem. That's because the hospitals will never gain money if all people will know everything about that. Okay? Ay nako. And that's very clever and business. Okay? Okay? So effort na lang jud talaga. Every individual must have our own effort. Okay? So this is an example, right? You work like this, blah, 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 so and so like this. Okay, a lot. This is butyric acid. Okay, it will produce butyrates, and butyrates are the metabolites. Okay, metabolites meaning they are the one who really give that energy in terms of the dietary fiber. It's very useful in our digestive tract. Okay, what is the formula circulatory of the butyrate? Okay, I'll show you. That is an ester. Okay. Oh my gosh, 8:40 already. Ester is an organic chemistry and salt is in an organic chemistry, but the same concept behind. It's all salt, something like that. Okay. Okay. My gosh. Okay, I have read the banana rich in potassium, calcium, magnesium. Oh my gosh. Okay, I'll teach you something that what the fruits and vegetables has its own color. So what is the acid responsible for that? That this banana changed to yellow, the apple changed to pinkish red. So the acid responsible for that is the malic acid. Okay, malic. Without the malic acid, the skin of the fruits will never change. Okay, so the change of the skin color of the fruits or the citrus fruits and the native vegetables are due to malic acid. 4 atoms of carbon, 6 atoms of hydrogen, and 5 atoms of oxygen. Maybe it will come out in the examination, for example, in the board examination, whatever. So blanc is an acid responsible for the changing of colors of a citrus fruit. A, butyric acid. B, stearic acid. C, hydrochloric acid. D, blah, blah, blah. And you will be confused because you never encounter that in your high school, in your college. I'm not arrogant. When I was in high school, I already read books, okay, in the library, okay, and in college also. Okay, that's why I really expand my knowledge through in the library. So there's a lot of theories I found in the library, okay, in the books, okay, a lot of terminologies, because that will be explained by the instructors during your college days. And then at that time, also when I took up chemical engineering is also very difficult. Okay, and then I challenged myself. Oh, really? It's difficult, right? I do my very best. Every vacant, I go to the library. Okay, because I'll never drink alcohol. Okay, something like, gosh. I rely on the natural process of alcohol, which is the glycol that can be produced by the intake of the glucose, okay, or due to the triglycerides reaction that will produce glycerol. It's because glycerol is a sugar alcohol. Okay, natural process of producing an alcohol inside our body, not the processed alcohol with the whiskey, the wine, the tanduay, whatever. We still have our alcohol in our body. That's why sometimes we feel also, drunk even though we didn't drink alcohol because there we have an alcohol inside our system already. Okay? My gosh. Oh, very big banana. My goodness. Oh my gosh. Banana, right? Oh my gosh. Oh my gosh. By the way, every individual has its own body odor. Okay? So many not know. So Sotero, what is the chemical composition of the body odor? So the body odor, it depends on the smell. It could be sour, it could be pungent, it could be unpleasant or offensive, it could be sweet. It depends on kind of the odor, but basically that is a propionic acid. I will discuss what is a propionic acid. Okay? Propionic acid is the body odor that will release day by day. Okay? So there's a formula for that. Okay? Later I will show you what's the formula of propionic acid. Okay? Like this. So in the common examination also, what is an acid responsible of sweating and of odor, body odor? Like this. So the answer will be propionic acid. So again, starts with letter P. So meaning to say, it is equal to propane. And then we apply the carboxylic functional group, and then we can discover again the formula. Something like that, okay, later. I will never touch first the acetic. Acetic is very easy, right? Acetic acid. The acetyl group is very easy, right? Because it's only having 2 atoms of carbon, something like that. So later, last will be the acetic acid, the vinegar. I'll explain also to you the vinegar. Okay, my gosh, that we use in our cooking. Wow. Banana has fructose. Yes, fructose, a sugar. Disaccharide sugar. Okay. The same formula with the white sugar. Carbon 12H22O11. Okay. That's why I never put white sugar because I can gain sugar by these fruits. It's just the same. Okay. Because this will produce sucrose also. Okay. Like that. So fructose plus glucose is equals to sucrose like this, right? Remember that one? Fructose plus glucose is equals to sucrose. Oh, ganon. Okay, maltose, glucose plus another glucose is equals to maltose. Then lactose is equals to galactose plus glucose. So meaning to say, this maltose, lactose, and sucrose are disaccharide sugars. It will never be produced naturally. It will be produced through the process of combining those monosugars. Okay, like this. We need to identify so that we can identify the characteristics and behavior, why it will produce diabetes, type 2 diabetes, like blah, 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 hyperglycemia. Will come out if too much intake of glucose, glucoses. Glycemia meaning from the term glycogen. The glycogen. Glycogen is a polysaccharide sugars composed of glucoses. Okay? As stored. This is a storage house of those glucoses there. Okay. In which my gosh, the glucagon hormone will try to communicate the insulin hormone. Ganon. Okay, to regulate the level of the hepatic glucose, the glucose coming from the liver, okay, like that, and the glucose in the blood, okay, blood glucose, okay. And now we'll ask us, what is dextrose? Hala, what is dextrose? What is the formula of dextrose? I'll show you later. Dextrose that you will put in the hospitals, I'll give you the reaction. That's why if you put, we will try to discover, we will put dextrose, the patient will survive a little bit because of that. Okay, so there is that components in dextrose that will allow the patient to breathe properly and inhale properly. Okay, that's why dextrose will be put to the patient, right? When somebody admitted to the hospital. So dextrose is also a sugar. Okay, and what is the formula of dextrose? Later I will show you. My gosh, dami. Okay. Oh my gosh. Dextrose, no? Dextrose sa propionic acid, right? Oh, hello guys. Propionic acid is the body odor, as I mentioned a while ago, right? Ako minsan sa'yo, di nila gikan imong baho, of course, that is coming from propionic acid. Okay? So, propionic acid. Wow. Ay, Diyos ko. Higher level na ba itong acid na ito? Actually, this is not really a long chain fatty acid. This is still this is still short chain. Okay, propionic acid. Oh, ito. Body odor. So, Sotero, what is the function of this propionic acid? Charot. It will try to control the growth of the bacteria and fungi to store poultry, grain, and hay, Hay, something like an animal feeds. Feeds, right? Animal preservative, something like that. Okay, and kill the herbivores, meaning those are insects that will kill or will prevent or will destroy the growth of the plants. So that's what we call herbicides. Those are herbivores. So that spray will kill them so that the plant will grow properly. Okay, like that. So this is the application also of propionic acid, aside from being a body odor. And take note, my gosh, take note, very important for the animal feeds. But take note, this is also application of preservative. Oh my gosh, it's very dangerous, right? Propionic acid, why? Okay, because in organic chemistry, this is very organic. Organic plants and animals or any food or substances have so many applications. It depends on the situation. Have multiple variety of applications. This propionic acid also, not only to control the growth of the fungi and bacteria, okay, for animal feeds or whatever, it can also be used as a preservative in foods like the cheese, CHEESE, okay, the baked goods like the pastries, the cookies, the cake, like that, okay, and used as an additive for fruit flavoring juices. Oh my gosh. Okay, the juices we have, the pack juice, the bottle juices, the additive for that fruit flavoring also combined with propionic acid because this is a preservative. Okay, but it will never be mentioned there as a preservative. They're very clever, right? Very smart. The manufacturers of those pack juice, bottle juices are very clever. They don't put this propionic acid in their ingredients also. Okay, you know the story? Because some will research that this propionic acid is a preservative, just like the sodium benzoate, right? for the soft drinks, okay, that try to deplete the carotene. My gosh, the carotene amino acid that produces too much energy in our mitochondria of the cell of our organ. Grabe. Okay, like that. The carotene, I mean, it's like that. But good for soft drinks, they mentioned really the sodium benzoate as a preservative. But here in other, uses, they don't put the propionic acid. Why? I don't understand. Okay, but I don't know. Maybe there's alternative. You don't know, right? Okay, so that those are the application of propionic acid. Okay, so we need to produce propionates as a conjugate base of propionic acid. Oh my gosh, just like the butyrates, right? Okay, it's gonna be like this. Propane! So, 3 atoms of carbon. Hello. Okay. Carboxylic acid functional group are carbon double bond oxygen, OH. This one. Okay, remember this one, it's carboxylic acid. Okay, citric acid, okay, and ascorbic acid, which is the vitamin C, obeys this formula also. Okay, so you need to say, if you take the vitamin C, you take also carbon atom in your system because ascorbic acid is carbon. Okay, like that. So we need to say, if there's no carbon atom inside our body, we will also die because carbon atom found in all substances that we eat or in the vitamins we intake, multivitamins we intake. There'll always be carbon atom present, especially this ascorbic acid or all acids, organic acids. Okay, like that. That's why normally when we do the releasing of our what do you call this one in English, the bad smell, okay, fart, FART, so due to the carbon, okay, and oxygen, okay, oxygen plus carbon dioxide, because we normally expel the carbon dioxide in our system, okay, through exhalation. Okay, inhalation, we intake the oxygen and we exhale the carbon dioxide, and then we release that one also. Okay, it's a cycle. Okay, like this. That's a Krebs cycle in biology. My gosh, Krebs cycle talaga siya. Or citric acid cycle. My gosh, grabe. Okay, ganun siya. Then R is propane. Okay, 3 carbons. One, like this. My gosh. Same story, ha. If there are 3 carbon atoms, you need to put 3 carbons also in the functional group. Okay. So carbon 2, carbon 3. Okay. Already did the carbon. So we need to adjust the hydrogen already. So put hydrogen. Okay, hydrogen, 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 hydrogen. So be careful also, some textbooks also don't put hydrogen because it is understood to be hydrogen by theory in this carbon like this. Okay? It is understood. Sometimes they don't put the hydrogen here, they don't put other textbooks, okay? But most of the textbooks putting hydrogen, okay? Based on what I know, I did in my college days. You can really discover something. This textbook is different from another textbook. Only the author are different, something like that. And you can discover what are their differences in their presentations of their discussions, topics to topics, okay? You can really see that in the introduction of the topics of the, within the books, the content of the book. Okay, something like that. So count the carbon. So this is CH3, CH2, okay, COOH. Ganon. This one. CH3, CH2, COOH, CH3, CH2. In this case, I don't memorize the general formula of propionic acid. So by this time, I can create the general formula by counting, right? So how many carbon? 1, 2, 3. So 3 carbon. First time. Okay, because I didn't do this so many years. So hydrogen, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 6. Oh my gosh! Hydrogen 6. Oh my gosh! And oxygen 2. Hala, ganon. Oh, this is the first time I encountered a formula like this. C3H6O2. It's slightly the same with the lactic acid. Remember that one? Lactic acid produces a lactate conjugate base that is very severe to the patient who have diseases. If you have a higher lactate from the lactic acid, then that patient needs proper oxygen to survive. Okay, because this lactate works more in the absence of the lesser presence of oxygen, especially you have a disease. At the time your lactate substance will be rising of a patient in the hospital, that could mean that there's a chance or possibility that you can never recover. Okay, because your organs will not function properly if there is a higher level of lactate, which is the conjugate base of the lactic acid. That's why we need to release the lactic acid during walking, exercise, physical activities, because this will remove through the sweat, SWEAT, because the sweat, one of the compositions of sweat is also lactic acid. So that's why it's very, very helpful also to do exercise to remove the lactate in our body, which is an identification by the doctor that our organs will not function properly if we get sick, if we have high level of lactate. And I thank you. Ganon. Muna na siya ha, lactate. Very important identification din na siya. Okay, so it's closer with the lactic acid formula, which is C3H6O3. But this propionic acid, which is also a body odor, is C3H6O2. Na-slide lang siyang usa sa oxygen. Wow, bongga. Okay, like this. So sometimes also examination will have like this also. What is the general formula of a propionic acid? And then we'll try to trick you out the formula of citric acid, ascorbic acid, malic acid. There are a lot of acids. There's thousands of acids naturally and artificially occurring. Okay, and you will get confused because you did not encounter that one. So the only thing you can answer is to be having your own initiative to read, explore different kinds of books and sources. Not only Google, because the Google, sometimes also other sources are wrong. They provide wrong, I'll see wrong. There also sometimes the number of atoms are not really correct. It depends on the source. Okay, that's why I don't really rely 100% for the Google search. Okay, really, I observed that before. Okay, I discovered and prove it sometimes wrong. Okay, like that. So this is the propionic acid C3H6O2 equivalent to the CH3, CH2, and COOH. This is the body odor. Okay, and the food preservative and the animal feeds preservatives application of propionic acid aside from being a body odor. Okay, ganon siya. And then we need to show the chemical equation. Sir Sotero, how can we produce that propionic acid? Okay, so that we can produce this body odor, okay, or this preservatives, okay, like this. Okay, I'll show you the reaction. This is esterification reaction, okay, ester, E-S-T-E-R. The functional group is this, ester. Oh my gosh. It's somewhere closer to ether. Can you remember this in your organic chemistry? You have organic chemistry or not? I think it's closer to ether, E-T-H-E-R. Okay, I think so, but not sure. Okay, okay, esters. Okay, ganon, or a salt, or a conjugate base of the acid. Okay, it starts with the reaction of water to the base or esters. Okay, something like this. Since we need to produce the esters, then we need to reverse because we know the acid already, which is a propionic acid, right? So C3H6O2 propionic acid, right? Propionic acid plus the alcohol or hydroxyl group. Not necessarily an alcohol hydroxyl group, but it's OH negative. Okay, OH negative. Okay. Okay. So is that really why you're showing like that? Because we don't know yet the element involved. Actually, there are a lot, right? Sodium, potassium, magnesium, calcium, manganese, phosphorus, sulfur. We don't know yet what kind of element involved. So that's why we need only to illustrate that is an hydroxyl group. If there is, for example, sodium, this is also sodium hydroxide. Okay. For example, if we eat salty food, automatically inside our body, we have sodium hydroxide. Okay, automatically, because that's being a part of HCl. Okay, neutralization reaction from hydrolysis reaction if we intake the salt plus the water. Okay, something like that. But in here, there's no element being identified for the purpose of discussion only. Okay, so, but if this propionic acid is inside now in our system, then a lot, because a lot of minerals inside our body. Okay, so many, I think millions. Okay, we cannot count one by one. Okay, I think let's just try one to be in the reaction. Okay, to make our presentation valid in the discussion. But let's just try to make it simple. Okay, OH negative only. Okay, so this will produce propionate char. Okay, so the propionate, hala ka diha. So C3, I will show you propionate plus water. Laoy. Go, John. Okay. Ester is equals to, example na siya sa a lot of esters naman siya. Okay. So we have the, my gosh, propionic acid C3H6O2, which is the body odor or the food or animal preservatives, plus the OH negative could either be alcohol or the base that involves OH, okay, is equal to the propionates now, the conjugate base of this propionic acid, plus water. Okay, if we try to apply our inorganic chemistry, so this is neutralization reaction. You know why? Because this OH is a base and this is acid, propionic acid. Reaction of acid and a base is a neutralization reaction, and it will produce a product that is also a hydrolysis reaction by adding water. But this is organic chemistry. In the context of organic chemistry, we don't, though the same principle, but we'll never use the terms. Here is the esterification process or the ester. Okay, the ester is here in the product. Okay, plus water always, because this is the ester. This is a propionates. Okay, ATE, right? ATE, the past tense of eat is ATE. I ate an apple yesterday, so it was being happening. Or it happened already. So very easy to understand. Oh, ester Sotero is a past tense of eat. Bingo, ATE. Okay, so propionates. The last three letters. Okay, Ola, butyrate, okay, acetate, manganate, like that, sulfate, silicate, ATE. So that are esters inorganic and salts in inorganic. Okay, the same principles behind. Okay, propionates, this one. Okay. So if I say silicate, okay, that is a salt of silicon dioxide. Okay. Silicate, which is the raw material of cement. Okay, propionate plus water. Okay, this one. So muna siya ang propionate. Okay. To balance the chemical reaction, wow. So 3 carbon, hydrogen 6, hydrogen 6 plus 1, 7, hydrogen 7, oxygen 3. Perfect. So ideal chemical reaction. Without doing anything, the reaction has just balanced immediately. Meaning to say, this is an identification, my friend, that is a naturally occurring chemical reaction. by nature or by natural process inside our body, if that will be balanced automatically without doing anything, just like this, it will become balanced immediately, right? I don't put atoms on the right side and the left side. So, that's naturally occurring substances like this, naturally occurring chemical reaction. And then this is a reversible reaction. So just what is a reversible reaction? If you try to reverse the reaction, it would have the same product and the reactant would be the same also if you try to reverse, because some of the irreversible reaction will not go back to its original reaction. That's irreversible reaction. Okay, like that. I think it will just go back only, most probably by adding a catalyst. Okay, but not really that also, all the time. Okay, but mostly are irreversible, irreversible reactions. A lot of irreversible reactions because there are a lot of, environmental physical factors due to temperature, pressure, volume, concentration, or the solubility. Let's say the heat of vaporization, okay, radiant heat of the sun, something like that. The conduction, heat transfer through conduction, heat transfer to convection, and the heat transfer through radiation, which is the beta, gamma, and the X-rays. Okay, that's three types of radiation. Radiation also is one of the heat transfer. Okay, like that. Heat is being transferred from one point to another or from one substance to another. Okay, something like that is heat transfer. So this is also environmental factors or physical factors that could change and could affect the chemical reaction. Okay, sometimes density also. Density. I think most of them are physical properties. Physical properties listed in the Chemical Engineer's Handbook. In the last part of the book, there are a lot. We have the surface tension, the boiling point, the freezing point, the melting point, the viscosity, the diffusion rate, something like the molecular weight, atomic weight, the density, the specific gravity, okay, the density, okay, like that. The thermal insulation rating have also, right? Thermal conductivity, right, in insulation. You remember that one also? Okay, and a lot more. So those are physical properties, okay? Like this. So that could change and affect our chemical reactions. But under normal circumstances, natural process, okay, assuming that we are just having an ambient temperature, ambient between 20 degrees Celsius to 25 degrees Celsius, and the surrounding air, that's ambient. If you meet the term ambient, that could mean between 20 degrees Celsius to 25 degrees Celsius air surrounding temperature. That is ambient temperature. Okay, it's just only in the ambient range or at STP. STP, standard temperature and pressure, like that. So it will never change that much. Okay, so most are reversible reaction. Reversible, just like this. See. Okay, this is actually neutralization reaction, and if you reverse hydrolysis reaction, okay, this is a esterification reaction, blah blah blah, so and so. Okay, like this. Okay, this is the propionate. Okay, tapos na tayo sa propionic acid ha. Okay, i-show na nako diri, di ba? Tanawa. Yes. So the last will be acetic acid. Oh, I love vinegar. Okay, this is very simple because the formula is just only HC2H3O2. And at this time, this acetic acid or the vinegar is, aside from having a small number of atoms between carbon, hydrogen, and oxygen, okay, like that. So C2H3O2, C2, small, right? 2 atoms of carbon, 3 atoms of hydrogen, and 2 atoms of oxygen. It's more higher than the propionic acid, which is 3 atoms of carbon, 6 atoms of hydrogen, and 2 atoms of oxygen, right? Now, this acetic acid can either act in other way around. It could be an inorganic and also an organic. It can only be on the organic part if we will add the polysaccharides. Oh my gosh, ano ba to? Polysaccharide sugar, which is the cellulose. Okay, cellulose is the major component part of the plant cell wall. You remember that one? And in a global scale, it will produce 100 billion tons of cellulose per year all over the world. Okay, cellulose. And cellulose is the most abundant compound in the planet Earth. Okay, this is trivia, right? Maybe it will come up in the examination, board examination, or whatever, science examination. And apart from the oxygen, is the abundant element in the planet Earth, but this cellulose is the most abundant compound in the Earth. See the difference, compound and element, huh? Because sometimes it will mix up sometimes during in a quiz bowls, quiz B like that. Because I love quiz bowls before. It helps a lot also. So those watching quiz bowls like this, reading books, help me a lot in passing the chemical engineers board examination. Frankly speaking, okay, I think it's about 60% up. Okay, due to my own learning. Okay, only 40% for the for the instructors to learn a lot, something like that. Okay, science basketball in Korea is competing with the Philippines, like that. Vietnam. I always watched that in the TV before when I was at 20s. Okay, the Battle of the Brains, like that. I love those programs like that, but the time come, it will lost in the TV already. Program it's been disappearing. That's why there's no more like that. It was changed by too much comedy, the social media, not really that good anymore for our children. So things that are nonsense, useless, always laughing, comedy like this because they said laughter is the best medicine. But through that, our students also will never learn academic already because they're too much laughing, comedy, and doing bullying, something like that. So they learn bad in social media instead of using it in a right way, something that in this millennial period. But compared to the past, so there's a lot of quiz bowl, science quiz bowl, history quiz bowl, mathematics quiz bowl, something like there's a lot of competition like that all over the world. Where in country to country are competing, something like that. I love that programs before in RPE 9, Channel 9, because before we don't have internet, okay? Right? We don't have technology before because we are not having that much. We are living in within poverty level, something like that. So I just gained my college education through academic scholarship, something like that. Okay. So that's the reason behind. So the academic learning has been deteriorated for most of our young generations, except to those few who have really a good upbringing and training by their parents. There are also some or few, but most or majority are not trained really academically. They are trained for other things that are superficial, shallow, nonsense, useless. For example, bullying, like that, criticizing, like that, doing jokes all the time that is very irrelevant already. Okay? Irrelevant and negligible. Okay? Something like that. It's good to laugh, but if you laugh every day, you are a fool. Or you're crazy already. If you laugh every seconds, every minutes, every hours. There's a time for that, and there's also a time for academic learning. Okay? Such like this. Okay? Oh my gosh. So you should learn also what is science all about. Epidemiology, physiology, okay, biology, like this, okay, because learning will never stop, something like that, okay. So I don't know, I cannot understand the world now, okay, because you try to check the YouTube, millions of viewers for those who are talking nonsense, okay, but only few viewers are talking the academic learning and have beneficial helpful effects to the humanity. Check that, okay, in the YouTube. If you watch, it's useless, okay. It gets you only to laugh, that's it, but nothing. It doesn't help for our health, okay. It doesn't solve our our stomach pain. It will never solve our headache. It will never solve our diabetes or obesity, it will never solve like that. But keep on laughing, and then the stomach are very bulging. And then burden, heart attack. Okay, too much laughing, heart attack. See? Because watching only comedy shows every time like this, because laughter is the best medicine. Yeah, it's best medicine, but you should not do that all the time. Okay, like that. Just like this, me academic, I'm never doing this all the time. Also, I'll sing. Okay, I'll do the exercise. I'll dance. Okay, I'll vlog cooking. I'll vlog other occupational safety and others. Not only about also academic. We have to be, flexible in our subjects and topics also. Okay, that's why Michael V saying he found a lot of basura content in YouTube. Okay, because this Michael V is a genius, a comedy genius. That all of his jokes have learning and lessons out of it. But those other, I'll never speak. Okay, too much. Okay, like this. Okay, so that's propionate, and then your acetic acid, right? Very simple, right? Okay, C3H2. Okay, C2H3O2. Oh my gosh. Ganun lang siya. Muna siya ang suka. C2H3O2, vinegar, dato puti, something like that. Okay? So 2 atoms of carbon, 3 atoms of hydrogen, and oh my gosh, 2 atoms of oxygen. Ganun lang siya. No need to illustrate because it's very easy, right? Okay. So acetic acid is used in cooking. Aside from that, what are the application of acetic acid? By the way, in organic chemistry, it should always be binded with organic compound to be applied in, for example, in a photographic film, like that, okay, in making tiles. This one, tiles. Okay, it become hardened due to this cellulose acetate, something like that, okay? Cellulose acetate. Imagine, you can just imagine, right? Cellulose is a multiple of sugars, right? Based on our theory. So the formula of cellulose are, my gosh, are 4 times of beta glucose monomers. I don't have to illustrate because it takes a longer time, okay? Four beta glucose monomers added together. So that is the cellulose. That's polysaccharide sugars. And this is cellulose acetate. So understood there's a sugar and this acetate. But why the application is on the tiles? Don't you think the tiles are having sugar? We cannot eat the tiles, not the floor. Okay, sometimes we need to imagine like this. That means the sugar there is used only to harden, okay, the material, something like that. Not really for the intake as a food. Okay, the cellulose acetate can be used in photographic film and in making tiles. And also in printing press, in making books. Oh my gosh, cellulose acetate. Oh my gosh. And then the vinyl acetate. The vinyl is the organic compound, huh? And the cellulose is the organic compound. It's only added in the acetate of the acetic acid. So I'm telling you, the application of this acetic acid in the organic chemistry point of view is just we have to add organic compound and just attach the acetate or the salt of this acetic acid. Imagine acetic acid, but there's a salt. Okay, sometimes if we don't try to dig it up, we cannot understand, right? Okay, the vinyl acetate is used in the making of plastic. Okay, because vinyl also used as a hardened substance like polyvinyl. So vinyl, like polyvinyl chloride, right? But this time this is vinyl acetate. The word vinyl used as a hardener, something like that, okay? To stick the molecules of the particular substance together, okay? To prevent leakages, something like that, or whatever, okay? That's why we have PVC pipe, polyvinyl chloride. So the vinyl is there, right? And the chloride is the salt. Imagine that is a pipe where there's a salt. Okay, chloride is a salt, right? So that means the salt there is used to harden only. Okay, the same as this, the salt acetate is used only to harden the tiles. Okay, so meaning to say there's a lot of okay, but there's a salt in it if you try to break down the chemical reaction. Okay, vinyl acetate is used in making plastic. Okay, aside from polypropylene, high density polyethylene, okay, like that, and olefin. Okay, because I've worked in Saudi Kayan petrochemicals, I know also the components of making plastics and tupperwares or any hardened plastic. The propylene, HDPE, olefin, and this also cellulose acetate, and also the cellulose butyrate. Oh my gosh, in fairness. The word cellulose also, okay, the word it's very hardened, right? Because we told you already that cellulose is the major component of the plant cell wall. Major component siya, di ba? So that's the characteristic of a cellulose. That's why it's being added to the salt to become a hardener, something like that for some certain plastic materials, like that. Okay? And now we know already a bit. Okay? Something like that. Okay, that is for acetic acid. It's the conjugate base of the acetic acid, which is the acetate added with cellulose and vinyl, which are the organic compounds that make it applicable in certain industries in producing photographic film, plastics, and pen for the printing press. Okay, something like that. Okay, because cellulose butyrate also used in making plastic. Okay, something like that. Okay, this is acetic acid. Okay, acetic acid is a weak base. Oh, weak acid, sorry. Weak acid. Okay, so I will show you the reaction so that why kulba. Okay, my gosh. So this is C2H3O2, acetic acid, the vinegar, plus OH negative is equals to the, oh my gosh, I hate this. C2H2, oh my gosh, what's happening? Plus water. Oh my gosh, wala, oy, grabe na to. Talaga. Oh my gosh, through constant exploration, this is the first time I see that formula. This one. Because I explored too much. Okay? You know, I have a work being a safety engineer, right? 8 hours per day. And after that, in going home, I need to explore, read, research, because I have my YT channel, something like that. And for further learning also, like this. I found out that there is a formula like this, C2H2O2. I did not know this before. Okay, this is the acetate. Just now formulate. Imagine how many years. I mean, I took up the chemical engineering 2000, right? 2000 from now, 21 years. Oh my gosh. From 21 years up to now, just now discovered that there is C2H2O2 acid. Maybe already there, but I just not memorized. Okay? Like that. This is the formula of, oh my gosh. This is the formula of acetate, C2H2O2. Okay? Because we understand that this is only one proton of hydrogen being shared to the acetate. So it's become C2H3O2. Okay, like that. Okay, so plus water. Oh my gosh. So this is the weak acid and the base, and this is the salt plus water. So it's better to say that this is an organic chemistry, not the organic, right? Because there are only small numbers of atoms. Okay? But it still obey the carboxylic acid group. Sure. Okay. Really? Yeah, it will obey because there's oxygen. Okay. Here it is. Acid that has no oxygen atoms will never obey the carboxylic acid functional group because in the carboxylic functional group have oxygen. Okay, for example, hydrochloric acid, carbonic acid, sulfuric acid, phosphoric acid, oxalic acid, chromic acid, okay, permanganic acid, okay, like that, chromic acid, my gosh, okay, perchloric acid. We have perchloric acid from the perchlorate polyatomic ion. Okay, so remember that one, perchloric. And then those acids that are not based on the carboxylic acid in organic chemistry because there's no oxygen. Okay? But still the same acid. Okay? So we now learn a bit about propionic acid, butyric acid, acetic acid, and some of their applications and functions, the chemical reactions, and in combination in relation to the healthy lifestyle of any individual. Okay, thank you so much. Thanks for watching this live streaming. It took me about almost 2 hours to do this live streaming. Thank you so much. If you are not subscribing yet my channel, then you can subscribe now. And if you like this channel, then of course you can comment anything. Okay, like that, and then you can also share to anybody else if you want to, and then click the notification bell for some newest updates of I am a singer, eternal voice. Bye bye, see you later for my next vlogging topic and for my next live streaming topic. This is again I am a singer, eternal voice. Baboosh. Wow. Charot. Ay nako. Ganon.